time to turn our attention to financial problems. Everybody's had financial problems, especially when we take a look at something like example 29, which I think we can all relate to, income tax. That's definitely a financial issue. Now, this person is a consultant, but it could be anybody, it doesn't matter. But the important thing is the income taxes here that they had to pay is $4,867. And if that was the end of the story, we'd be okay. But this person also had to pay an extra 28% of the amount of the taxable income that exceeded this amount. And this is the hardest part of the whole problem to come up with, is this little formula. It said let X equal the taxable income dollars that exceeds this amount. If X is exactly this number, the amount of extra income is going to be zero. If she paid $32,451, that would be $1 that would be taxed at this 28%. Its total tax is going to be the tax that they already owed plus 28% of the amount that exceeds $32,450. And that is going to equal this number. So this is going to be the equation that we're going to start with and solve. Now what we want to get for our total tax bill here is how much we're paying in income tax and how much extra we're going to pay for the amount that has exceeded the 32450. Now 28%, as we saw before, is really just 0.28 as a decimal. So we have here is the 4867 plus 0.28 times this equals 7285. What we're going to do is we're going to subtract both sides with this, and that's going to end up on this side as 2418. Once we have that, we can then divide out both sides by 0.28, and that's going to give us this. Now we're going to carry an extra digit beyond here just to make sure when we're finished, we're going to round to the nearest dollar. Let's carry a little bit more accuracy. So if we add 32450 to both sides, then that's going to give us X is this to 0.7. We take the 0.7, we round this up, and our final answer, therefore, is going to be $41,086 to the nearest dollar. Well, let's take a look at example 30 here. A person invests part of his $10,000 at 6% and the remainder at 8%. And we saw this set up a little bit earlier. We said let X equal amount at 6% and 10,000 minus X is the amount invested at 8%. Now let's take a look at how we would sort of set things up, and we're going to do this by sort of working with numbers to get a better idea, and then we'll set up our equation. Before we get started, we're told that X is the amount invested at 6, and therefore 10,000 minus X is the amount invested at 8%. And before we even think about that, let's look at an example that gives us some very simple numbers to work with to get an idea of what's going on. So let's assume that half is invested at 6% and half is invested at 8%. Half of our dollar value is 5,000 times 0.6, that gives us $300. The other 5,000 at 0.08, just to give us some rough numbers, that's 400. We add the two, we get $700. And that's how this thing should work. Now we saw X is the amount of the $10,000 invested at 6%. And what we did previously was we said, what happens if X is $5,000? Then this means that this is going to be 10,000 minus 5,000 is $5,000. So that would be an equal split, where one is invested at 6%, one is invested at 8%. And we saw the number that came out of this was $700. So we thought, maybe these two amounts are pretty close to being the same. Let's see if that bears out with what we do. So we write down 0.06x, because 6% of X plus 8% of the difference should give us the amount that they gave us in the question, which was $750. Now what we want to do, what we need to do at this point is get rid of the decimal parts of 0.06 and 0.08. And the way we can do that is multiply this entire thing on the left-hand side by 100, also multiply on this side by 100. So when we do, this is going to be 6x plus 8 times all this, and then we multiply this, we add two more zeros, so we end up with this equation here. So we have 6x, let's collect like terms, 6x minus 8x is minus 2x. If we subtract 80,000 from both sides, we're going to get this is equal to this, which means minus 2x is equal to minus 5,000, or x is equal to $2,500. If we are right the $2,500 is what we invested at 6%. And I think it's fairly obvious that a $10,000 minus X is going to give us $7,500 to make up the total of $10,000. And what we have to do is check our left and right side to make sure that this is going to work. So this is going to be 0.06 times 2,500 plus 0.08 times 7,500. When we work that out, this gives us $150 here plus 600 here. This gives us a total of $750. So this indeed is the correct solution. We've invested $7,500 at 8% and $2,500 at 6%. Let's take a look at exercise 3 and some financial problems we see here. The labor costs for a certain project, on question 1 here, was $3,345 per day, and there were 17 technicians and helpers total. If the technicians earned this much a day and the helpers earned this much a day, how many technicians were employed on the project? To solve this problem, let's let the number of technicians be T and the number of helpers be H. Altogether we have technicians plus helpers equal a total of 17 people. Each technician earns $210 a day times the number of technicians is the amount that's earned per day by the technicians. We also found that $185 a day are earned by the helpers times the number of helpers. And this is going to give us a total of $3,345 a day. Now let's call this equation 1 and let's call this equation 2. So we have two equations. And what we want to do is take the first equation and write it as T equals 17 minus H. And then we can substitute that into the second equation. So we can write the second equation as 210, then we substitute in 17 minus H for T plus 185H, and that's equal to 3,345. Now at this point we're going to multiply 210 by 17, and that gives us 3,570 minus 210H plus 185H equals 3,345. Now what that ends up being is 3,570 minus 25H equals 3,345. If we subtract 3,570 from both sides, we get minus 25H equals 3,345 minus 3,570, which gives us minus 25H equals minus 225. And if we divide both sides by minus 25, we're going to get that H is equal to 9. Since our original equation said that technicians are equal to 17 minus number of helpers, technicians is equal to 17 minus 9, where the number of technicians is equal to 8. Now what we have to do is validate that this is the correct values by substituting into our equation and checking. I think you can see easily that T plus H is 17, validates quite easily here. And if we take a look at our second equation, it's 210 times 8 plus 185 times 9 gives you these numbers, which gives you a total of 3,345. So the second equation here does match, and our solution of technicians 8, helpers 9 does indeed validate. Let's look at exercise 3, problem 3. How much to the nearest dollar must a company earn in order to have $95,000 left after paying 27% in taxes? Now let's let X equal the total earnings before any taxes are taken off. So there's our total earnings, and there's our tax being taken off the total earnings at 27%. And the amount that we have as total earnings minus our taxes is our $95,000. So this is our formula. Now if we multiply both sides by 100, we're going to get 100x minus 27x is this number, which gives us 73x is this number, and when we divide it out we get this value here, but we want it to the nearest dollar, so the value is $130,137 to the nearest dollar. Now before we can do anything else, we have to check to make sure that this is the right value. So let's do our checking. Now if we substitute our number here in for x here and here, we're going to get this number minus 0.27 times the same number, and that works out to this, subtract this, which is going to give us our 95,000. So the left side and the right side do match, so this is a proper solution. Let's take a look at question 6. What salary should a person receive in order to take home $40,000 after deducting 23% for taxes? If we let X equal the salary before taxes, then here's our salary before the tax man gets us. Here we take away 23% of our money to get our amount that we want, which is 40,000. Again, if we multiply each side by 100 and do the math, you should end up with this result here. And if you validate it, you will see that yes, indeed, that is the amount of money you got to make to get $40,000. Let's take a look at this problem. A person is $450 in debt, owing a certain sum to his brother, twice that amount to an uncle, and twice as much to the bank as to his uncle. How much was owed to each? So let's let X equal the amount owed to his brother. The amount owed to the uncle is 2 times what he owes to his brother, and the amount owed to the bank is 2 times what he owes his uncle, so that's going to be 4x. So x plus 2x plus 4x equals 450, 7x equals 450, so x is going to equal $64.29. Now if you plug these in, this is what he owes his brother, this is what he owes his uncle, because it's twice as much and twice as much again to the bank. And when you add all these up, it comes to $450. So this is indeed the amount that's required. A student sold his used skis and boots for a total of $210. He got 4 times as much for the boots as for the skis. What was the price of each? Let's let X be the amount for the skis and Y be the amount for the boots. Now the total amount for skis plus boots was 210, so that's X plus Y equals 210. And it said that the boots, which are Y, were 4 times the value of the skis. Now what we're going to do is we're going to substitute equation 2 into equation 1. So everywhere where we see a Y, we're going to replace it with 4X. So we've got X plus 4X is 210. That gives us 5X is 210. When we solve, we get X is equal to 42. And 4 times that is going to give us 168 for our boots. And when we add these two together, we do indeed get 210. So that is our solution.